Family, welcome back to the channel. Fix It for Reselling. We've been to the auction. I wasn't going to bid on this. No one was bidding on it, and I won it for a £5. So including fees, it's probably about £6.50 or something like that. But I was just plugged it in to test it, and yeah, we got issues. Otherwise, I wouldn't be bothering making a video. Let's get into this one, see what's wrong with it, and see if we can fix it. Run the intro. Right, this is going to be so awkward to film. I've just twisted it around. Right, this should be a 6-piece stacking system. When I've looked up on the internet, I'm missing a double cassette deck and the record player. Sold online at £655 for the whole setup. I do have the speakers as well, they're in the other room. But yeah, I mean, this was sold. It was up as spares or repairs. So I was wondering when I got it. Right, so this is the amplifier. Where did I put that lead? Hold up. Shaky camera. Right, sold as spares repairs, but I was wondering if it was because of those leads, because they all have these leads. Apart from the tuner has its own special lead because that only needs 16 volts, I think it was. The graphic equalizer and the CD player need 240 volts. They all have like the American plug, or European plug, should I say. Is it American or European? Right, so those two that I've plugged in there are for the CD player and the graphic equalizer. This one is for the amp. Now luckily I do have one of these plugs laying around that I can plug that into. So let me just get this in here. Right, so that's nice and dry. So basically that just like, they clip into there. Click in, shuts down, and that's your American plug into a UK plug. Plug it in to be fire hazard. So now we do have a red light on the amplifier, so everything should turn on. I've already set the tuner so you can see the time flashing away, but if we turn this one on, should turn everything on. So as you can see, the tune's on anyway, but we're getting nothing from the graphic equalizer or the CD player. No signs of life. So the amp's okay, tune's okay, these two. But let me tell you what I've already done. Right, so what I have done, I've taken that plug, God's sakes, and I've directly put one of these into there. I've only done the graphic equalizer just as a test, and the graphic equalizer turns on. So my guess is it's these two extra inputs. Whether the fuse has gone inside, I can't see a fuse on the outside, but the AC settings are right. It's over there on 240 volts. So yeah, so we're going to get this apart, see if it's got any fuses on it, see why there's no power going to these two sockets. That's what the problem will be. Right, let's quickly whip the screws out the side and the back. These things weigh a ton. This looks disgusting in there. Look at that dust. Dust. Oh, cobwebs. Look at that. Man. God knows where they've kept this thing. I mean, under that, it should be green. Yeah. Ooh, it's not looking pretty. Ooh, dusty, dusty. Really, this is going to need a strip down. Down in here, you can see. Let me get the Hoover. This is a fucking disgrace. I'm surprised if this is even going to work.
I feel like David McGee.
Thank you, my beautiful assistant. Nicola, you filled this up. Oh, I'm surprised this thing even turned on. I mean, there's shit everywhere. I mean, rubbish, crap, whatever. Be careful putting your fingers anywhere in here. It's you could get high voltage. I know this is a low voltage area, so I'm okay touching bits in here, but you could have some big caps down here that are still charged. I think I'm going to have to strip this down fully. I mean, our fuses are down in there. You can probably see there's one there, and one down there. But it's just covered in detritus. Let me just see if I can get in there and check these fuses. So we just put that onto continuity mode, so it beeps. Fuse 1 is good, which I suspect is the main fuse for the amp. Fuse 2 is good. Don't know what it's for. And the one at the back is also good. So why do we have no power going to these external back parts? Right, I think my work's going to be cut out on this one. Yeah, I mean, for a fiver, I don't know whether this is too far gone. Because the amplifier is where the money is, and so is the graphic equalizer, which I know is working. Is it worth my time? Yeah, got nothing better to do at the moment. Right, let's just start taking all the back off this and taking it apart. But I thought one thing I need to check first is to see if there is voltage on those outputs. So we've got our multimeter set to AC, and if we just plug it into one of these, fiddle around until we get to the thing. So I've got 241 volts on that one. On the other side, no, see there, yeah, I've got 240 volts in that side as well. So we have got voltage coming out of there. So why, if I now plug this into the back of here, why has this got no voltage? If there's 240 volts coming out of there, we're going to plug around and hold it in different places. Makes no difference. It's definitely on. I can hear the relay clicking. Yeah, got nothing in either side. Right, another quick test. I've got this cable plugged into the back of the amp. You can see 239 volts on there. So let me just pull this out to show you. It's going to drop to 0. I've got one of them plugged into the amp and into here. That's one side, fine, 239. The other side, fine, 239. It's weird because it doesn't matter whether the amp is on or off. Still got 240 volts, so it's not like it's being switched. But then if I take the power lead for like the CD player, watch the voltage now. As soon as I plug this in, gone, 3.4 volts. So it's like it's a short, but this isn't short because we know we can put the plug on it and it turns on fine. Turning the amp on and off makes no difference. You can hear the relays clicking. So yeah, for some reason when we plug this in, take it out, 240, plug it in, 3.5 volts. So I don't know why that is. Let's take these out before I just touch the metal or electrocute myself. So yeah, I'll take the back of the amp off again and investigate. Right, I did check all these fuses. All the fuses are fine. There's a couple more under here. Those fuses are fine. I don't think we'll be getting 240 volts out there if the fuses weren't fine. So let's try and work out where the power is going from to get to these. So this is our live and neutral coming in, which are basically at the bottom of there. So that is our neutral that joins up, so that just joins straight up to the neutrals on the back of here. So this will be our positive, so you want to see, or our lives, so you want to see where these are going. That's going nowhere, that's going nowhere. No, what am I talking about? What am I talking about? Nothing there. It jumps across there. Phil jumps across that wire. There. Not there. Nothing there. That's the fuse there. So it jumps across this wire. Comes down to here. Which is nothing. Test point. Anything up this side? No, there's nothing up that side. So that basically comes down to this bottom point here, which is our relay switch. And that capacitor. Is that a capacitor? So what is that filter lined up with coming back here? So yes, it's... So this is our relay switch that then comes back up here as well. So the line's coming in and coming to the relay switch, which is then going through the relay switch and coming back up here into there. So if that relay's on, the power's coming through. I'm not too sure. I think the transistors on this side of the circuit are all for that connector that comes down to here and gives us our, is that our voltage for the tuner? What we got here? System control. No, so that one next to it's the power for our tuner. So that's like the system control power. We're looking at here, we've got these other two wires that are on this side of the transformer. So I think that's what brings. Does that bring the voltage in? I think this brings the voltage in down to this connector. Down onto here. Which probably takes it from here into the main board. And then the relay switch here is connected through these 2 points. Now this relay switch needs 12 volts to turn on, and all the paths are leading over to this connector. So that leads me to this area is the relay opening, which you think it would because these are connecting and you're getting your 240 volts out. But I'm just confused about all this at the moment. So I thought, you know, from there to here it goes through these couple of resistors, the transistor, and there's a diode there. So let's check the back of here for those resistors, just see if they've got like normal readings. So where are they? So these are the two resistors. Ugh. On this side 4.7 kilo ohms, that's a standard resistor reading, and 10k, so hopefully they're right. And then we've got a transistor in the middle and the diodes at the end. So we're going to diode mode. Let's test this diode at the end. I think it's a Zener diode. So it's 0.014 that way, that's an odd reading. Go the other way, and 0.014 again. Right, so that diode is open. It's definitely a diode. Yeah, Zener diode. So that's probably a 12, well, it'll be higher than a 12 volt Zener diode, won't it? Because this relay needs 12 volts to open. So is that why it's staying on all the time? I don't know. Let's try and have a quick check of this transistor. Not sure it's NPN or PNP. Don't know which is the base. What is the collector? Well, it doesn't seem shorted or open anyway. I've got a diode reading that way. nothing seems shorted, so maybe it's just, maybe it's that diode. So yeah, maybe it's this diode in here, which is obviously there on the back of it, and these are the 12 volt pins that are on the relay, which will open and close the relay. Is it that? Is that our problem? Let's get it off and have a look. Let's unsolder that and check it. Oh god, I've got this tidy tip on. It's a diode out, missing a leg now. There's a leg has snapped off of it inside here somewhere. There, so maybe that is our problem. I'm going to turn it off and change the tip over. Yeah, I can't even test that out of circuit now. So, not sure whether that was me just now, or whether it was kind of like gone. Well, it's showing it's shorted anyway. But yeah, I don't know whether I can, let's see if I can find a schematic for this. Probably not. We'll have a quick look. Right, so we found the schematics. We just entered up the Kenwood and the A-85, the model number, and we came up with this. Going through the schematics, this is a part of the diagram we were interested in. So it's actually written on the board, if I can get this into shot. Yeah, so it's written on the board what the components are there, like Q7 is your transistor, D12, that's your diode. Got 2 resistors there, which is 130 and 131, I think. So they're all marked on the board for you. So, found out the part we was interested in, which was this part over here, and here you can see that is our D12. Usually it's kind of like gives you some more information, like when you have a resistor. I mean, that resistor there that we read, the 130, is saying it looks like 430 on there, and we was reading 4.7. Yet the resistor 131, the other one we read, it says 10k, which was 10k. And you'll sometimes see a quarter there, which means it's a quarter watt. So you can get like quarter watts, half watts, 1 watts, which are usually the resistors are different sizes. You can tell by the length of the resistor whether it's a quarter, half, or 1 watt. Bloody blah. So yeah, so that's our D12. On the bottom here, we've got it all listed of what stuff was. Oh, that's not printed out. That did say D12 on the screen. So our D12 is this diode, a 1SS131 or an HSS104A. And Q7 is, that is a Q. Q7 is 2SC2003. So that is a MPN transistor. So we've had a quick search for the diodes. So our diode D12 was a 1SS131. 1SS131, yes, exactly right. Or the HSS104. So if you search for the 1SS131 diode and then put equivalent or datasheet equivalent, you'll usually find things that will tell you what an equivalent part is for that. Because, you know, these are old, things get updated, so you can replace them with newer parts as well. It's actually a high-speed switching diode, which is at 4 nanoseconds, and it's got a rating of 80 volts. So a diode usually just lets the flow through one way, and as we can see from here, so that broken diode was actually showing as shorted. It was showing, you know, pretty much like 0 voltage both ways. So this relay that needs the 12 volts to switch on the back of here, you can see it down the bottom. Yeah, so that was shorted together. So I don't think this relay's operating, so I'm not sure how 240 volts was passing through here when I was measuring it. But hopefully that's got something to do with why the voltage was dropping. Maybe this is trying to turn on and just totally shorting everything. Oh, I don't know. Right, let's come back up. In my treasure trove of like parts. This is just like one drawer of many. I usually just keep diodes in here, but I've got a few extra bits. These are all like parts that the old guy that used to live here, that sort of died here, he used to, I think he used to take lots of electronic components apart. I found jars full of stuff. And I've kept quite a few bits, and these are bits that I've added to it now. I've taken, like, you know, diodes off of things you can't fix and scavenging parts off other boards, and I just keep them in a drawer of diodes, drawer of resistors. So we found one on our equivalent list. The first one was a 1N4148, and in my pot this one says T4148, but I believe the beginning part, just the letter, is just like the manufacturer. So I've looked up this code and what this one is, and this one, I mean, this one says on here that these is 90 volts, but when I looked up this code it said it was 100 volt. So it's greater than 80, so it will do the job. Haven't tested the transistor again, but hopefully the transistor is going to be alright. So yeah, so in my drawer of scavenged parts off of broken stuff, I hopefully have got the right high speed switching diode. So we'll pop this one in and see if it makes any difference. You know, and this, with your older equipment, this is what everything used to be like. You used to be able to get schematics. You used to be able to find out what every component on the board was. And a lot of times in the 80s, 90s, probably not so much in the 90s, you used to be able to actually go back to the manufacturer. They used to have, a lot of schematics would have a part list at the end of it and a part number. And you used to just go to the manufacturer, say, I want this part number, and they'll be able to supply it for you. That's how easy things was back in those days. Now it's like everything's top secret. People don't like you repairing your own stuff, and you don't get these schematics anymore. A lot of times these, on newer equipment, these are hard to find. You know, Apple won't give you anything like this. PlayStation and, you know, Xbox and stuff like that. Microsoft, they're not going to give you like any information like this. And sadly, that's the case with a lot of stuff now. A lot of times, if you want to find out what a component is, you have to buy a working one to then look at what the component is, or ask someone else that's got a model to take their machine apart and ask them what the component is, what it's reading. But even again then, you don't really know, you know, the actual ins and outs of details unless you can look online and find all this stuff up and find equivalents. Anyway, enough of worrying about people not letting you fix your own stuff. Right, so let's move this out of the way so it doesn't fall in and short anything out. It was definitely broken before I took it out, before I broke the leg on it. Right, so always remember which way you took stuff out, because it's a diode, it only lets the electricity flow one way, or the current flow one way. So you need to know. Luckily in the old days they marked it up on the board, so we'll get our black line there, and on our diode we have a black line. So is it the cathode? Is it the cathode or the anode? You have a cathode and an anode on these. Just going to prep this ready for the new component. I'll clear these holes and get some new soldering. Right, so I'm just going to get some fresh solder, clean my tip a bit. So just clean these up. Right, so that's our holes nicely cleared, out the way light. There we go. So I want to make sure we get this in around the right way. Right, let's use the tweezers to try to get this in there. So I can't get my fat fingers in. Right, that's in there. Just bend them feet over a bit just to hold it for now. Nicely soldered in. Bit of IPA, just get rid of some of this flux that's now on the board. That's it. Job done. Right, so now it's back in place. Just check our diode readings again. So that's reading 0.4. Swap our leads around, do it the other way. And that's reading 0.4. 394. 384. That's going to the emitter.
God, what have you burnt out?
I've not burnt anything out, Nicola. It's called vintage electronics, Nicola.
Sits on the lungs.
Sits on the lungs, does it? Things I have to put up with. Right, so I've just popped the little transistor out that was at the back of this board. Right, so yeah, that transistor that was in there, Q7, just thought I'd measure it out of circuit, so it didn't quite look right. Right, I've looked up the code online, which was what was it, C2003. So it's a NPN transistor. So with the numbers facing you, the flat side facing you, we have the collector, emitter, and base. If we go on to the base, base to emitter, with our meter and diode reading, we get nothing, no diode. Now our base to our collector, we get our diode reading, 0.6, but there's no diode reading to the emitter. So if we go around the other way with our negative on our base, I think these should be open. So yeah, base to emitter is open, base to collector is open. Yeah, and then our emitter to collector, come on. Yes, it is showing open, so we're just missing a reading from the base to the emitter. If I put it in my little my cheapy component tester, that is showing us a diode between the collector and emitter. So it's not showing that it's a NPN transistor. And by the power of editing, I've already taken this off and already ordered some components. They're not exactly the same, but you can go on a website and get the equivalent. These are the equivalent. I think the voltage rating's higher. I think these ones are 80 volts, like constant power they can handle. I think these are probably like 100, 120. I can't remember what they were now. The only difference is these were, the old one said it was up to 70 hertz. These ones are only up to 50 hertz. But because it's going into the mains, our mains is 50 hertz, they should be fine. And it was listed as an equivalent. So it's the BC639. So yeah, so here's one of the new ones, BC639. If I put that in the component tester, you can see comes up as a diode reading. 1 is the emitter, 2 is collector, 3 is the base, which is correct. So when you measure these in diode mode, where's that bit of blue tack? So we got a diode reading from base to emitter, diode reading from base to collector, if I can hold it still long enough. Round the other way, open, open, base to collector open. So let's pop this in and see if it makes any difference whatsoever. Make sure I get it in around the right way. Get it looking nice and level and bend the legs a bit. Right, let's just solder this on. Beautiful. So what I think maybe is happening, I think we're getting our 240 volts from our negative side. I don't know whether that works. And then we're not getting our 12 volts in here to open the relay and get our 240 volts from the positive side through the relay. Relay's not opening and send it over. So I think maybe when we're reading 240 volts, are we just reading the negative when it's on minus 240? We're not getting the plus 240 as well. I don't know. I don't know. Right, let's plug this in roughly and see if we get anything different. I'll quickly put the back plug on because it just holds these loose bits in place. Don't want anything touching the frame and making the frame go live, do we? Ooh. Right, let's just plug this in and power it up. Make sure nothing pops and no smoke comes out of there. Nicola wouldn't be happy. Any more electrical smells in this place? Right, it seems to be turning on. Let's just turn it off a minute. Unplug it. Put the lid on and we'll test it how we tested it before. Right, so we have our CD player plugged in. And our test wires also. Let's plug it in, see what this says. 3 volts still. So no, it's not that. Unplug CD. Back to 240. What is that? Let's see if I turned it on. I've turned it on. 240. Just heard the CD go. It was that. You klutz. So when it's off, so now the relay is off, and that's the 3 volts we were reading before, which is correct. The voltage isn't going through, so it's cutting the live out. So when we turn it on, the relay now comes on because of that component we just changed, and now we're getting 240 volts with both of them plugged in. If I remove that before I touch them, now this CD player should be on. I can't see it. Hey! There we go. Where's the graphic equalizer? Where is that? Right. Our graphic equalizer. Just take the just taking the lead out the back we were using to probe and test. Plug the graphic equalizer in now. See, let me turn the front off. Right, that is plugged into the back. Let's remove that. Right, I'll tip this up so you can see. Right, so the stereo is turned off. Can't get this camera any wider to show you, so go a little bit. Right, turn the amp on now. Go. There we go. So that's what it was, that transistor not turning the relay on. So the 240 volts we were reading, I think, was just the negative side of the 240. That is done. Love that. Love that when you can work something out just by testing the component. Alright, so obviously I cannot sell this in this condition. It is absolutely caked. You know, just all that crap down the side. Doesn't look so bad on the camera, but there's cobwebs, all sorts in there. It's all a bit, you know, rusty in here, and so it would need stripping down and, you know, dusting off. Quick wipe over. You know, you kind of like got this pitting on here as well, but I think that's just on the surface. I don't think that's underneath. I've already given that a wipe over, so stop any rotten corrosion. There's obviously one thing I haven't tested yet either. I haven't tested that the outputs are all right. I've checked for DC voltage on the back, there's nothing. So we now need to see if we can actually get some sound out of here, or hook up some speakers. Right, just hooked up some of our cheap speakers, our test speakers. I'm not worried if they go pop, they're just out of the soundbar. We've hooked in our iPod to the auxiliary one. Right, let's turn the volume down, press play. Is it going to make any sound? Yes, it is. That's a quarter of the way for these little speakers. They're both working. We got a balance. Yeah. It's a balance. There's nothing on the right. No, we've got this one and not that one. We have sound. Should really have been something I checked first of all before taking it apart and fixing the other issues with it. So I've also plugged in the CD on the top. We have a rather scratched up copy of Red Hot Chili Peppers in there. Let's put this on CD. You can't see what I'm doing, but I'll put it on CD. Yeah, that says no disc. I wasn't saying that earlier. Yeah, now it's reading it. If the CD plays anything like the amplifier, then this is probably just going to be a dirty laser if this isn't working. Play. Yeah, you can hear that's working. I'm not going to play that for too long because that's obviously going to be copyrighted music. Right, I've just been listening to that a bit further, and it does start to skip, but you can probably see that is really, really scratched. And I have tried like a normal CD, which is in good condition, and that is skipping also, so probably just got a dirty laser. But we've got sound out of it. Got sound out of it, we've got power out of the amp. I don't know whether to include anything else in this video at the minute, or whether we should just clean this amplifier out. Maybe include a bit of that. Strip the amp down and clean it. Let's have a quick look at this laser first. Just gotta get the laser back. Here it is. Looks a little bit cloudy. See what it looks like after a little bit of IPA on a cotton bud. That looks much better, I think. That one's spinning fine. Yep, turn that off. That's going to recognise what that tune is. Right, so that's playing. I'm going to keep my eye on it, make sure it doesn't skip. Right, this has been playing for a while now and seems perfectly fine. So I'm going to give some of this a little wipe down. I'm just going to clean everything up now, get the amplifier in bits, clean it up. I'll show a few shots when the amplifier's apart. But that's about it for now. Right, take all the ribbon cables out of there, the screws. So So here's our first board to clean up, and you can see it's just covered in muck. Sure, this is pretty much, well, God knows what it was. Dust, spiders' eggs. Muck. So what's going to do is take this apart, clean them up. This is slightly dampening my brush down. Just to help get some of this off. Just need to make sure it's like perfectly dry when I put it back together. Because it's only damp, it will be fine. But this is just from cleaning the outsides of these cases so far. Absolutely disgusting. Any bits that are more stubborn, just get a toothbrush in there. And hopefully as you go further down, it's not as bad. This one's just dust. Back of the boards are absolutely perfect. Nothing wrong with them, it's just the crap that's in the top. So just going to give these all the dust down.
by the lakeside. Gotta do it while we're young. In a moment it will all be gone. You gotta understand that we get one chance, one chance. You will never regret the things that we'll do. 'Cause I wanna drive through the summer night. And we are going great. Look back at this summer.
Right, there we go. It's all fixed. Even the remote control is fully working. We've got all the bits. We've got all the control, the connectors around the back, and it's working a treat. I can't fault it. I might need to clean the or re-grease the spindles on the CD. It was jumping, but now it's playing absolutely fine. So I think it might just be the spindles need a bit of re-grease. Maybe the grease has got a bit sticky because it's playing perfectly every time now. Press the play. There we go. It's working. It's got a mechanical volume, so with the controls, you can see the knob turning up and down. So for £5 I'll pay for this. £5 hammer price plus £1.20 on the premium. Absolute bargain. Little bit of work. Taking me probably about a day, but it's probably well worth it. The amplifier can sell for £100. Graphic equalizer probably again £80 to £100. The tuner will probably sell with the amp because that's probably only £30 maybe. And the CD player goes for about £60. So from a £5 investment to over £200 sold price, even the remote on its own is probably £20, which I might do because I'm splitting the whole thing up. Speakers, don't know, can't find anything about them. But yeah, we took the chance at auction, took a gamble on this at a £5 spares and repairs, wasn't even going to bid on it, didn't notice it, we won it, we fixed it, and we're going to make a good bit of profit on it. So give me a thumbs up if you like the video, please like it, please comment, please subscribe, please share it, and I hope you enjoyed this video, and hopefully I shall see you in the next one. Thanks for watching.